Okay, let's talk about everything that we know. So, first we were talking with Philip. Philip, what did you say? That green dot is the focus. Exactly. You know what? Ms. Liz made a really good point. It's not really part of our graph, right? We just use it to identify how far away or how wide our parabola is going to be. So she made it an open circle on the quiz. So that is our focus. What else? Let's hear it. This is the vertex. Good job. Go faster. Let's hear it. The red line is the directrix, but it technically should be dotted, right? But we pulled this off of the internet because it's not part of our graph. It's just a reference. It's a guideline. Yeah, it's a boundary line is exactly what it is, right? What else? Let's hear it. The distance between the vertex and the directrix is P. Fantastic. Give me more. Philip? The distance from the focus out to any point, but not any point. It has to be a straight line out, right? It has to be a 90-degree angle. That's 2p. What else? There's more, Sarah. All the way across is 4p. Good. Yes. It's always 2p. Yep. It's always cut in half. Philip, what else? The focus of the vertex is also p. So actually, this is 2p, and this is 2p, and it'll always make a perfect square. See that? There's a connection there, right? Let's hear it. 4p is my LLR. There's more. Ooh, we need to put that on the quiz. The distance from the parabola to the focus is the same distance as the focus to the directrix? Yes. That's actually the definition of a parabola. It's not 2p though. 2p is the 90-degree angle, Lucas. But I could also, remember when I did this? I think it was in this class. Let's do it with, use a black line. Okay, anytime now, right? All right, so if I start at the focus, any point on the parabola, if I take that line, that distance, if I copy it and paste it, it will be equidistant to the directrix. Correct? Move the wrong one. You know what it is? It's because let's just send that to the back. And I can grab it. There it is. So that is going to be equidistant, always. So let's explain that a little bit more. Any point from the focus to any point on my parabola is equidistant to that same point on the parabola down to the directrix. Lucas. It does not. It does not have a special name. But it doesn't matter where I do it. I could draw one all the way up here, right? If I continue my parabola way, way, way up here, then it would be equidistant to a directrix. That's what you did with the folding activity. Exactly. What? You get it? Are we missing anything? We're missing one thing that I'd like to still bring to our attention. Anybody have it? Where's the x? Well, we're not really concerned with where the x-axis is because we don't even have numbers. But there's one thing that I could still say about this graph. It's positive. Good job. Yes, I was just going to give you a candy. It's positive. Right? If it was negative, it'd be pointing down. Good job, guys. Ooh, I love it. It also has a relative minimum. Good job. I think that's it. I think we covered all of it. Okay, let's move on. Can you guys fill this piece of information in? So basically what I want is I want you to give me the equation of that parabola. On your whiteboards, please. The equation based on this parabola is graphed right here. Recording? All right, so very important. I need my vertex. My vertex is at 0, 0. That means I have no horizontal shift, no vertical shift, but I can measure P. P is 1. Double check. P is 1. That means this distance should be 2, and the whole thing should be 4. So I would say 4P is 4. I don't need the y minus 0. I can put it up there if I want to. So really, it's just 4P equals x squared, because I'm not shifting, not P, 4y. Questions? You seeing the connection? Yes. Yes. All right. So why don't I create another one for you? Let's do focus is green, right? Hey, if my focus is 2 away, how wide is my parabola going to be? Because if it's 2 away, that means my directrix is also 2 away, which means my focus is going to go out 4 with a total of 8. So can you guys give me the equation of this graph, please? On your whiteboard? All right, so if I know my vertex is at positive 2, then I know my horizontal shift is going to be 2, right? The opposite of 2 is negative 2. And my vertical shift is also 2. I should put 2 and it's negative 2. 4P is 8. Questions? That's it. That's the equation of the graph. Another one? Okay. Okay, how about let's make that our vertex. Let's put our directrix here. So if my directrix is there, where's my focus going to be at? 1, 2, 3 below. 1, 2, 3. And how wide is it going to be? 12. Because if this distance is 6, then I have to go 6 out, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Give me that equation. Please. All right, so my recording kind of missed the last slide. But what did we miss? Oh, that's okay. That was last week's stuff anyways. All right, so completing the square. Thank you, Christopher. So before, we used to have it like this, and we would complete the square. Now we're going to involve that y. All right? So this is how this works. So the way I explained to you guys before pictorially was that x squared, if I were to complete this square, okay, I hear shifting behind me and I want it to stop. Remember, I have to add something to both sides in order to complete my square. Right now, my square's got 4 x's. So the first thing I do is I split those 4 x's in half. So I have 2 x's on one side and 2 x's on the other. So to complete my square, I would need 2 squared. 2 squared, or 4. I should have done all of that in a different color. What color? Purple. Well, actually, I've got red on it. I'm going to be really, how I get weird. I've got red on there, so I'm going to make it red. Okay, so in order to complete my square, I would need 2 squared, or 4. So I'm going to use a commutative property here and switch them around so it looks like something that I already know is familiar to me. Y plus 4 equals, this perfect square is x plus 2 squared. And the reason for that is, I'm just going to do this really quick. If I took x plus 2 times x plus 2, I would get x squared. That's x times x. 2 times 2 is 4, or 2 squared. And 2x plus 2x makes positive 4x. Isn't that what I have here? So I created myself a perfect square binomial. So the only thing I have to do now to make it look like how we would have it if we graphed is put parentheses around this, and what would be my 4p? Not p, but 4p. What would my 4p be? Just be a 1, right? So if my LLR, let's put it in pink, because pink is pretty. So if that's 1, my LLR is 1, and my p is that cut in half, which is a half, and then cut in half again, which is a quarter. Thumbs up, thumbs down. One more? You want me to do one more? Okay, I'll do the harder one. And then I'll give you guys the easy one to do on whiteboards. All right, one more. So I'm going to complete the square. I'm going to go quicker on this one. So I already have my 4y. I have x squared plus 4x plus something squared plus something. I say to myself, if I had an x squared and I split up my 4 x's, then I would need 2 squared to complete it, which is 4. So this is 4y plus 4. 4y plus 4 equals x plus 2. I'm having issues today. X plus 2 squared. So there's only one thing I need to do to put it into transformational form. This is not transformational form. They both share a 4 in common. So I can pull a 4 out, or factor out a 4. Now it's in transformational form. It has a horizontal shift of -2, vertical shift of -1, and it's 4 wide. So if my LLR is 4, how much is P? If I cut 4 in half, it would be 2, and then I cut 2 in half, that would be 1. Question? How are we doing? Good? All right, you guys ready for one? Let's have you do the easy one first on your whiteboards. So do that one first. Some of you probably by now can actually visualize what that perfect square is. All right, let's see. Don't erase. Okay. So I immediately visualize this as being x minus 6 squared. How many of you did that? Some of you? Okay, I'm going to go back and not skip steps. But I knew if I had to add 6 squared to this side, I'd have to add 6 squared to this side. Right? I'm going to back up, so some of you aren't ready for that. So I'm going to say y equals x squared minus 12x plus something squared is going to complete the square. And I'm going to have to add that something on the other side as well. In order to complete the square, I would take 12x's and cut them in half. That would be -6 squared, which makes 36. And I would be done by saying y plus 36 equals x minus 6 squared. So that would be a horizontal shift of 6, a vertical shift of -36. My LLR is 1. Therefore, P cut in half twice is 1/4. It's always in the coefficient. If there's nothing, it's just 1. You guys ready for the one that's a little bit harder? Try that one. So 1. I'm so lucky. You guys are so smart. You're doing so good. Aw, Philip. Okay. So, how many can you visualize what my square is? It's 3, because half of 6 is 3. But I can't forget to add on the other side. How much am I adding on the other side? I'm adding 9. 3y. I have to add, because 3 squared is 9. Thumbs up, thumbs down. Can I skip that step right now? Are we okay? Good. So I have a common factor here of 3, so I should probably pull that 3 out. Okay. So my LOR is 3. Take half of 3, 1.5. Half of 1.5 is 0.75. Yes, completing the square is the only method, because we're making squares, right? And that square is what makes us be able to graph it? No, there's not 4 different ways. This is it. Good question. All right, 5, 4, 3, 2, 1. Okay, let's look at this, clearing fractions. So you guys would all agree with me, right, that if I wanted to, this would be an equivalent fraction if I divided everybody by 2? So I would get y equals 3x squared plus 11 halves x, which isn't that much fun, right, plus 15. So if you had something like this and you didn't want the fraction, what would you do? I would multiply everybody by 2. Multiply by 2. Multiply by 2. Multiply by 2. Multiply by 2. And I would get 2y equals 6x squared. The 2 and the 2 cancel each other out. Plus 11x. Thanks for the commentary, Philip, but I'd rather not have it right now. Okay. All right. So when you see fractions, they're not actually very scary, right? Because we have methods of getting rid of them. So what would I multiply each one of these by? 4, and I would get 4y equals x squared plus 12x minus 40. Right? What about this one? Multiply by 2. I would have 2y equals, ooh, yes, it would be negative because I want that coefficient to be 1, right, in order to complete the square. So if I multiply everything by negative 2, this would be x squared plus 14x minus 12. Thumbs up, thumbs down. Can we just move on? Cha? Okay. All righty. All right. Can I show you something really quick? Okay, check this out, guys. If I move 40 to the other side, wouldn't I get 4y plus 40 equals x squared plus 12x, correct? What would complete this square? 6 squared, right? So would I add 36 to this side? So I would have 4y. What's 36 and 40? And this isn't going to come out really nice because I should be able to take a 4 out of both of those, and then I would have my vertex, right? My transformational form. Let's do this one and see if it comes out prettier. If I add 12 to both sides, I would have negative 2y, guys, plus 12 equals x squared plus 14x. What would I need to complete the square? 7 squared. So I would add 49 to this side. 49, 59, 61. And then I'd pull a 2 out, but then that wouldn't be very neat either, right? Y plus 61 halves. You're still confused? Yes? No? We're good? Are we sure? I'm just showing you I can go from this to completing the square. This is an ugly number. But what does it mean? I mean, really, guys, what does it mean? How much is 61 halves? 30.5. It just means I'm shifting down 30.5. It still is an ugly number. I would never give you anything. I would never give you guys anything that ugly. Okay? So don't worry about that. All right. So do you guys want to write down your notes? Let's go to, how much time do I have? Let's go to here. All right, I'm going to ask you one more time. 5, 4, 3, 2, 1. I know you're anxious to start your homework, okay? Let's do this one. Then I'm going to let you get your notes written down, put in your notebook. And then I'm going to do one more, and then I'm going to give you your homework, and we're going to work on it the rest of the time in class. Okay? All right. Yes, Tristan. Okay. All right. Lucas, what am I going to multiply everybody by? 6. But before I do that, f of x, I'm going to call f of x y. Y equals 1/6 x squared plus 2x plus 7. Now I'm going to multiply everybody by 6. 6y equals x squared plus 12x plus 42. What's my next step? Move the c to the other side. So when I move the c to the other side, I get 6y minus 42 equals x squared plus 12x. Now I got to complete the square. What would complete my square? You guys already have it, right? X plus 6 squared. If I put 6 there, what am I going to put on this side? Good. 6y minus 42. plus 36. What's negative 42 and positive 36? 6? Negative 6? So I have 6y minus 6 equals x plus 6. What's the last thing I need to do? Factor out a 6. So what's happening to my graph? Can we describe it without even graphing it? What's my horizontal shift? I'm going to the left 6. What's my vertical shift? I'm going up 1. And how wide is my graph? 6 wide at the focus. Do you see how we can describe it without even graphing it yet? I can't. Well, I'll have the notes for you on the next slide. All right, I'm going to graph it. So that's what we just did, right? So I'm going to go ahead and graph it. And the first thing I'm going to say to myself is my vertex is at positive 1 on my y and negative 6 on my x. So I have vertex is negative 6, 1. It wasn't green, it was blue, huh? My vertex before, my focus is green. Issues, right? Yep. Negative 6, 1. So 1, 2, 3, 4, 5, 6, but up 1. There we go. Now our focus is going to be a little bit harder, right? Because 4p is 6. So 4p is 6. How much is half of my p? I mean, half of 4p. 3. So if 4p equals 6, then 2p equals 3. That means 1p equals 1.5. Not much fun, right? So in order to get to my focus, I got to go up 1.5. And get to my directrix, I need to go down 1.5. And it's 6 wide, so I'm going out 3, 1, 2, 3, and out 3, 1, 2, 3. Okay. Questions? I should put my focus on here. So my focus is at negative 6 up 1, 2.5. Negative 6 up 2.5. And my vertex is negative 6, sorry, my directrix, negative 6 and down 0.5. So that's y equals negative 0.5. Questions? Okay. Do you guys want to write the steps down first? You just want to write your example down? Okay, there you go. I'm going to pause it. All right, I'm going to go back to 1 because this is the hardest one on your worksheet. Okay. Can I get you guys to quiet down for a second? Thank you. All right, so I'm going to turn this to y first. Y equals x squared minus 6x plus 5. Move the 5 on the other side. It becomes y minus 5 equals x squared minus 6x. In order to complete this square, I would have to add 9 to both sides, right? Because 3 squared is 9. This becomes y plus 4 equals x minus 3 quantity squared. This has a coefficient of 1. So now, when I graph it, 4p is 1. So 2p is 0.5. So 1p is a quarter. And these are the ones that are a pain, right? So if my vertex is at positive 3, negative 4, so positive 3, negative 1, 2, 3, 4, there's my vertex. positive 3, negative 4. That means my focus is going to be up 0.25, which kind of sucks, right? And my directrix is going to be down 0.25. I'm going out a half and a half to make a total of 1. And there's my graph. The directrix is down. If I have to go up the focus, if I have to go up 0.25, it would be 3, negative 3.75. And my directrix, I'd have to go down another 0.25, so it would be y equals negative 4.25. Okay? You're just going up and down from your vertex. All right, have a great day, guys.